Alright, so a definite, which you could check with your GDC, which would be quite simple. You just put it in and you're finished. But let's say we had to do it by hand. Um, Again, we've got not very many choices. You can't do a substitution. There's nothing, it's not of that form. So we got parts. We could try parts, where u is ln of x squared plus 1. And therefore the derivative of u with respect to x is 2x over x squared plus 1, right? 1 over this times the derivative of it from the chain rule. Now, our only choice here is that this is 1. It's pretty tricky, but there's nothing else. It's just 1. So when you integrate that, you get this. Now, if we have chosen this to be ln of x squared plus 1, it would be pointless because we don't, you can't do that in the first place. So putting it all together by pieces, you've got ln x squared plus 1, right, times x. I'll throw that out front. I'm going to leave that sit there as part of my answer. Then I've got to integrate x times 2x over x squared plus 1 with respect to x, which is easy because dv dx, so dv is dx, and we're kind of off and running. Okay, so now I'm going to do this. And again, almost all these examples have ended up with some kind of long division being necessary. Okay, so we're going to take x squared plus 1 and see it go into 2x squared. So it goes twice, 2x squared plus 2, take those things away, remainder of minus 2. Okay, so we're subtracting the integral of 2x squared, of 2 minus 2 over x squared plus 1 with respect to x. And at some point now the light will go on and you shall see this just gives us minus 2x, right? And then this exists from our formula booklet. Minus minus becomes plus. The 2 sits there, and the integral of 1 over x squared is, or x squared plus 1 is arc tan of x. Okay, now it was a definite integral plus c, so we don't need the plus c. We were going to evaluate it from 0 to 1. So you take all this underlined piece, this and that together, sorry for that, and you evaluate it at 1, you subtract it, evaluate it at 0, and you get your answer, which I'm not going to do because that's the easy part.